Hello, Matthews, Gatos here. Did you miss me? Here we are, lesson number 2, chapter 5, page 253, exponential form and log form. So in the last unit, chapter 7, you guys were introduced to the log function as the inverse of an exponential function. So for example, the exponential function y equals 2 to the x had an inverse x equals 2 to the y. Now we couldn't use that form very well because we can't enter y or x equals equations into the calculator. So in the last unit, we also saw that was the same as y equals log base 2 of x. So an exponential function with a base of b has this equation, y equals a times b to the x. The log function also has a base of b and has the equation y equals log base b of x. So exponential and log functions are inverses of one another. They undo each other. So the opposite of taking an exponent is taking a log. For each of these, they both have the same base. So the base of an exponent is the same as the base of a log. It's the inverse operation of exponents versus logs which changes. And remember, we also looked at the fact that x has to be greater than 0 because you cannot take the log of a negative number. So that's the third thing we can't do in math. We can't divide by 0, we can't square root a negative, and we cannot log a negative number. So in terms of a logarithm, let's just review the different parts here. So when we have y equals log base b of x, that's how you say it, y equals log base b of x. B is the base, and the base is the same for a log and the exponent. Y is the value or the answer, and x, what we're taking the log of, is called the argument. And the argument can never be negative, which is why we have a domain x greater than 0. Now on your calculator, you guys have that log key, and that log key on the left-hand side of your calculator is just a common log. So when I hit log, that means log base 10. So log base 10 can be written without the base and just as log of 10. So on your calculator, your common log, that log button right here, is log base 10. Now, if you want to come up with something other than a base of 10, because most of the logs we work with don't have a base of 10, you're going to use math alpha math for logs with any other base. So let me just show you this here. So this is your common log, which is just a log base 10. But if you want to come up with the log template, you can go math alpha math, and it gives you this log template. And you can see, if I just back away my cursor here, you can enter in any base here and any argument here, and it will give you the value. Now, unfortunately, TI-83s, we aren't so lucky. I have a TI-83 as well, and we can't do that. So to come up with the answer for a log, we just have to do log of the argument divided by log of the base. And so when the 84s get this here is my base. This here is my argument. So TI-83s, we just do log of the argument divided by log of the base, alphabetical order. Okay, you can cross off that part there. The only time we ever do natural logs is when we do regression, so we don't have to worry about natural logs or a base of e. So let's look at log forms and exponential forms. So in the last unit, you guys already looked at something like this. You looked at a graph 2 to the x, which I have here in blue, using a table of values. I just plug in my x values there and come up with the corresponding y values. And then we also looked at the graph of a log function, so log base 2 of x. Notice the exponents are the bases are the same. And since they're inverses, the x becomes y, the y becomes x, and you can see here it's a reflection about that identity line of y equal to x, which is what makes it an inverse. Okay, so for both of these, the base is greater than 1. They are both increasing graphs. So increasing graph just means, if we look at the exponential, as x gets bigger and x increases from left to right. So I just read my graph from left to right, getting bigger for x. So as x gets bigger, you can see y is getting bigger, which is why it's an increasing graph. Same thing with the log. As x gets bigger from left to right, y is also getting bigger. So that's why they are both increasing graphs. So let's look at a couple of points on that graph. So there is a point on the graph of 2 to the x that has coordinates of -2 and a quarter. So if I were to replace x with -2, I would get a y value of positive 1 over 4. So there's my x value going in for x. My y value is going in for y. So if I were to put that together, I would have this equation. I would have that 1/4 is the same as 2 to the -2. Now, there was another point which was on the log graph, and that log graph had a point of 16 and 4. So if we look at that point 16 and 4, the 16 becomes the x value because that's the x coordinate. The 4 becomes the y coordinate. So putting that together, we would have this. 4 is the same as log base 2 of 16. So those are based on those points and a statement that we can make according to those points. So what I want to do is I want to look at a couple of other statements. So now I know that log base 2 of 8 is the same as 3. And exponentially, that's the same as 8 equaling to 2 to the exponent of 3. They're inverses of one another. So let's look at this inverse in a little bit more detail. I have a base of 2 here for my log. I have a base of 2 here for my exponent. Inverses are x and y interchanging. So you see how these are interchanging? So instead of equaling to 3, it now equals to 8. Instead of 8 being the x value, it's now the y value. So you can see that the x and the y value interchanged. So what I'm really looking at in this here is how do I go from log form to exponential form? So how am I going to go from log form to exponential form? If you look at the example of the statement that we know, the base is the same, x and y interchanged. To go from log form to exponential form, I can draw this big circle. 2 to the exponent of 3 is equal to 8. See, 2 to the exponent of 3 is equal to 8. This will work for all of my questions where I'm going log form to exponential form. So I'm going to use this here. I'm going to call it the circle of logs. So if I have a log form here, log base b of x equals y, and I want to switch it into exponential form. The base stays the same, it's just x and y that interchange. So I can go b to the y equals x, a nice big circle. So we've seen why that works graphically, so let's now apply it. Okay, so for example here, I can switch between log and exponential form. So log base 2 of 4 equals what? Well, using the circle of logs, I can figure that answer out. 2 to the exponent of that equals 4. So 2 to what exponent gives me 4? Well, 2 squared gives me 4. So that means that log base 2 of 4 has a value of 2. Okay, again, log base 2 of 2 equals what? So 2 to this unknown value will give me 2. So 2 is equal to 2 to what unknown value? Well, that value is 1. So log base 2 of 2 is 1. Log base 2 of 1 equals, we want to know what? So 2 to the unknown value will equal 1. 2 to the unknown value will equal 1. The only time you can equal to 1 with any base is if it has a value of 0. So 2 to the 0 equals 1, which means that log base 2 of 1 equals 0. Okay, so that's our first big piece of information. To go from log form to exponential form, we can use the circle of logs. This really tells me that what a log is the value of the exponent. So a log is the value of the exponent. What exponent do I raise the base to get to the argument? And that's what each one of these are. So if we look at this here, let me just erase it and write it again. The reason that log base 2 of 4 equals 2 is because 2 to what exponent gives me 4? Well, 2 squared gives me 4. 2 to what exponent gives me 2? Well, 2 to the 1 gives me 2. 2 to what exponent gives me 1? Well, 2 to the 0 equals 1. That's why it works that way. So now what we're going to do is we're going to look at the other way around. How do I go from exponential form to log form? So let's start with an example. I know that 2 to the exponent of -3 is the same as 1/8. Well, using what we know about inverses of logs and exponents, log base 2, see the base is the same, and I'm interchanging x and y. So instead of equaling it to 1/8, I'm taking the log of 1/8. So instead of equaling to 8, it will equal to, interchanging x and y, -3. Okay? So the way that this works, going from exponents to logs, I personally love logs. Well, you guys know that I'm a math nerd. I love logs so much, you could say that they are my bae. So since I love logs so much, to go from exponential form to log form, I'm going to use bae. Bae stands for base, answer, equals exponent. So watch here. Let's see if this is right. So base, answer, equals exponent, equals the exponent. This will always work. So to go from log form to exponential, use the circle of logs. To go from exponential to logs, use bae. So here's a statement. 2 to the negative 2 is the same as a quarter. If I want to write that in log form, I use bae. Log of base answer equals exponent. And look, you can use the circle of logs to check. 2 to the negative 2 equals a quarter. Yes, I did it right. Okay, so 2 to the negative 1 equals a half. Let's use bae. Log of base of the answer equals the exponent. And again, you can use circle of logs to check. You guys know I love my tricks. Okay, so circle of logs to go from log form to exponential, bae to go the other way around. Just remember that your nerdy math teacher loves logs. Okay, let's try this. So if I have 10 cubed equals 1,000 and I want to write it in log form, I love logs, I'm going to use bae. So bae, base, answer, equals exponent. 3 to the exponent of 4 equals 81, written in log form. Use bae. So base, answer, equals exponent. Okay, and again, if you want to check it, you can use circle of logs to check it. Okay, now I have some log forms and I want to write them in exponential form. So since I want to go from log to exponential, I use the circle of logs. So I just write this out here, and then I'll use the circle of logs to come up with that. So I'm going to go base to my answer equals my exponent. So 5 to the exponent of 4 equals 625. Okay? This next one here, log of 100, doesn't have a base. But remember, when I don't have a base, I have an invisible base of 10. So it's like log base 10 of 100 equals to 2. So I'm going to use my circle of logs. Base to the answer equals the exponent. So 10 squared equals 100. Okay, so going to exponential, use the circle of logs. Going backwards to switch to log form, use bae. Okay, so I'm going to use this to solve any of my questions. So here's what I do. If I have a question that I'm solving that's in exponential form and I can't solve it, switch to log form. If I have a question in log form that I can't solve, switch to exponential. You're always going to be going back and forth between the two different forms. Okay, so let's look at this. Let's convert to log form, from log form to exponential form, and we're going to solve for x. So again, I just use my circle of logs. So for this one here, I do base to the answer equals exponent. So 7 to the exponent of 4 equals x. And then I can solve this. So x is equal to 7 to the exponent of 4. We can leave it like, oh, we're just actually switching it to exponential form, so I don't have to do the answer. I'm doing too much work. Okay, so this one here doesn't have a base, so 4 equals log base 10 of x. Again, anytime you don't have a base, it's always an invisible base of 10. So looking at this one here, I can again use my circle of logs to go ahead and solve that. So I'm going to go 10 to the 4 is equal to x. So 10 exponent 4 equals x. Over here, using the circle of logs, I'm going to go 5, because I have a base of 5, I'm going to do 5 to the exponent of y equals 15. So 5 to the exponent of y equals 15. That would be my equation. And then on the last one, writing it with numbers, it's the same idea. Okay, so I'm going to flip these around here because it's going the other way. So I'm going base to my answer equals my exponent. So circle of logs, always starting with the base, t to the m equals the big letter B. Okay, let's convert each of the following from exponential form to log form using Bay. So remember, I love logs, so we're going to switch them to log form. So log of, B stands for base, A stands for answer, E stands for equals exponent. Okay, switch this to log form. Log of base, answer equals exponent. Here, log of base, answer equals exponent. Okay, now we're going to get into actually using these to solve some equations now that we've practiced how to switch between the two different forms. Okay, so in each of these equations, express the log equation as an exponential equation and solve for the variable. So here's what I do. If I have a log equation and x is the argument or the base, I switch to exponential form using circle of logs. Otherwise, I just evaluate it on my calculator. So I'm going to show you that. So I'm looking for where x is the argument or the base. Those are the ones that I want to change. Otherwise, I don't need to change it. So I need to use circle of logs for this one, and this one, but not this one, D, because I have the argument and I have the base. So I'm going to show you how to do that one in a minute. Okay, so here, use circle of logs. 6 to the 4 equals x. And 6 to the 4 means 6 times 6 times 6 times 6, which is 1,296. Okay, here, base to the answer equals exponent. So b squared equals 144. So I'm going to take the square root of both sides. And I get that b is positive and negative 12. But remember, the base has to be a positive number. So b can only equal 12. Okay, here, base to the answer equals exponent. B to the 3/2 equals 125. Oh, this is why we practiced these in the last lesson. So I'm going to raise this to the reciprocal power. So b is equal to 3/2 times 2/3, that's just 1. And then 125 to the 2/3 is 125 squared, and then I take the cube root, which will be 25. Okay, this next one here, I don't have to switch this to log form, to exponential form, because I can solve it just like this. I can just plug it in my calculator, or I can ask myself, 36 to what exponent gives me 6? Well, I know the square root of 36 is at 6, so I know it's 36 to the 1/2 equals 6. So I know that y equals to 1/2. But I don't have to do it that way. I could just put it into my calculator. So I can do math alpha math. What did I do wrong here? 6 to the, no, I don't, oh, I did this backwards on the calculator. Look at that, that's wrong. I was wondering, why did I get the wrong answer? Okay, let's fix this. Okay, conveniently, I have the log template waiting for me. So this is log base 36 of 6, and it is equal to 0.5 or 1/2. Okay, phew, I thought I made a mistake. Okay, so this is wrong, sorry. This should be log base 36 of 6, and then you saw that we got an answer of 0.5. Okay, so you can do this asking yourself that, or you can actually just plug it in the calculator. So only do the circle of logs when I'm solving for a base or an argument. Okay, let's look at this one here. So by converting from log form to exponential form, calculate the value of t. So for this one here, we have a couple of pieces of information. So we're going to convert, use one of them to convert, and then use the other one to substitute. Okay, so what I want to look at for this one here is I have that log base 2 of x equals 3 and log base 2 of t equals to x. So I have two variables here. And I can only work when I have one variable. So I can't work with that one yet. I need to go to the first one, and I'm going to do that using the circle of logs. So using the circle of logs here, I'm going to do 2 to the 3 equals x. Well, 2 to the 3 is just 8. So now I've done my conversion, I can now substitute. So x is the same as 8. So in this equation, I can rewrite it as log base 2 of t equals 8, because I can only really have one variable. And now I can just use the circle of logs again. So 2 to the 8 equals t. So that's 2 multiplied by itself 8 times, which is 256. Okay, looking at this next one, I have log base 5 of x equals t and log base 2, sorry, and log base t of x equals negative 2. I have two variables in this one here, so I can't work with that equation yet. I need to go to my first equation. Okay, so here, because x is an argument, I want to use circle of logs. So 5 squared equals x, which means x is 25. And I'm going to put that into my equation here. So I'm going to have log base t of 25 equals negative 2. So now I only have one variable. I'm going to again use circle of logs to figure it out. So t to the negative 2 equals 25. And remember, to solve this, I raise to the reciprocal power, which will be negative a half. So t to the negative 2 to the negative a half. Negative 2 times negative a half is just 1. And then 25 to the negative a half is take the reciprocal of the base and raise it to the positive power. And that's just the square root of 1 over 25. So t is equal to 1 over 5. Okay. This next part here, all I want to do for this one here, okay, is highlight the steps. So anytime I have an exponential equation, a times b to the x, if I want to switch it in log form, the very first thing I have to do is isolate the power. Once I isolate the power, the b to the x, dividing both sides by a, I just use, to go from here to log form, because I love logs, is just use bay. So isolate the power before you switch it into log form. Okay, once I've done that, if I want to write this in log form, I can do base answer equals to the exponent. Okay, so let's try that. So for each one of these, I want to isolate my power first. Okay, isolate my exponent first. So I'm going to divide both sides by 2. And then y over 2 equals 3 to the x. I want to go to log form, and I love logs, so I use bay. Base answer equals exponent. Okay, isolate my power first, and then since I love logs, switch using bay. Base answer equals exponent. That's an h. It kind of looks like a b. H over 7. There we are. Okay, for this one here, same thing, even though there's letters. Divide both sides by r to isolate my exponent. So I get t over r equals s to the p. And then because I want to switch to logs, and I love logs so much, I use bay. Base answer equals to exponent. Okay, so we're going to use this idea to solve a couple equations. Okay, so when we're doing, I feel like I'm missing a question. I am missing a question. Okay, so I don't have it in my notes, but I'm going to write it out because I thought we had to solve equations. Here we go. So 8a is log base 7 of y over 3 equals x. There we are. Okay, so I want to convert each of the following to exponential form. I just want to make sure I'm doing this right. Yes, I am. Okay, I'm losing my mind, kids. Okay, so 7 to the x equals to y over 3. And then the next one, log base 5 of 7y equals to x. So again, using the circle of logs, 5 to the x equals 7y. And then the last one, we don't use an e, but we're not really solving anything. We're just practicing converting. So circle of logs, e to the x equals y over 8. I don't know why that was missing in my notes. So now that I've done that, I want to switch it to exponential form. Y equals a times b to the x. So for each one of these, I just want to get y by itself. So to finish it off, let's go back here, multiply by 3. And then I get that y equals 3 times 7 to the x. Here, divide both sides by 7. So I get y equals, I'm going to write the 1 over 7 up front like that. And then on the last one, I just multiply both sides by 8. And that's gone. So y is equal to 8 times e to the x. Okay, there we go. I don't know why that was missing from my notes. So now let's summarize our lesson. So to write a log in exponential form, isolate the logs and use circle of logs. To write an exponential form in log form, isolate the exponent and use bay because we love logs. So this circle of logs idea that I came up with was kind of inspired by this song here, and let's just see if you guys recognize it. So I just want to set the stage here. Rafiki comes to the edge and he wants to prevent Simba, and he says that it's the circle of life. But here, this is how I saw it. It's the circle of logs. So that's how you guys can remember it. Circle of logs, and of course bay. So you guys can go ahead and do your assignment 1 to 16, omit 12C. Hope this video helped, and I'll see you next time for lesson number 3.